Bing! Carly's back today, thank the heavens. Now we'll actually get an intro. Okay, last time we did solving equations with base E, and I gave you a different piece of paper so that our equations that we were solving were applicable to what we needed it for. And what we needed it for was today's lesson, which is on page 92, and it is solving word problems that involve natural growth and decay. So, all of the equations that we solved today are like 3, 4, 5, and 6 from what we did last time. They're just slightly more complicated because the numbers are bigger and the percentages are smaller, but it's all going to be just fine. So, before I read any problem, all of your equations today are going to have the following form. It's going to be your end amount equals your start amount, E to the rate multiplied by time. So one of the biggest takeaways from what I just wrote down is that all of these will have a base E. All of these will have a base E. Okay, let's check it out. Strontium-90 is a radioactive material that decays according to this function here. So this is the same, this A of T, A of 0, blah, blah, blah. This is the same as what I just wrote down here. It's your end amount equals your start amount times the growth rate. So what they gave us is rate, which is R, which is this number. They gave us this number in that equation. It's this guy right here. I'll highlight that for you. What they gave us was R, and it's that part of the equation that they gave us. Assume that scientists have a sample of 500 grams of strontium-90. So this part A that says, what is your initial amount of strontium? 500. And then B, what is the decay rate of strontium? It's this guy that I wrote here. Negative 0.0244. What about this value tells you that it's decay? It's negative. So if your rate is negative, that means you're losing the amount. You're losing grams of strontium. Okay, the first question is, how much strontium is left after 10 years? Well, if we're using this thing, we would say our end amount equals our starting amount, 500, E to the rate of negative 0.0244 times 10, because they tell us T equals 10. So this here, I'll highlight that. 10 years means T is 10. So this guy we can just plug into Desmos. I'm going to go to the calculator, scientific calculator. I'm going to type in 500, letter E, shift 6, parenthesis, negative 0.0244 times 10. 391.7 grams. Did anybody else plug it in? Did you get what I got? Okay. So this is what we did at the beginning of this unit. We reminded ourselves what exponential growth and decay was. So that was page 76 and 77. And then the next thing we did were these word problems. So this is just one of those word problems. Part D is what you're doing today. So part D says, when will there be 400 grams left? So here's what we now have. We have a starting amount of 500 and an ending amount of 400. The rate is still 2.44%. And what they're asking us to find is time. Find T. So you have 2 quiz questions that ask you to identify these things. It's going to say, what's your starting amount? What's your ending amount? What is your rate? And then find T. Okay, so let's set up this equation. We have our ending amount, 400. Our starting amount, so 400 equals your starting amount, E to the negative 0.0244 times T. And what we have to do is solve for that T. Well, that's not too bad because we did this last time. So step number 1 is we have to get this 500 off of the E. We have to get the 500 off the E. Are you with me? So divide by 500 here, divide by 500 here. These go away. And now I'm just going to rewrite it with my E first. So E is equal to, just kidding, E to the negative 0.0244 T is equal to, 400 divided by 500. And I know that that equals 0.8, but I'm going to leave it as this big fraction. You can change it to 0.8 if you want, but this will be easier in the long run. Okay, now that this E is all by itself, you can take the natural log of both sides. So because E is all alone here, we can say natural log on the left side and do a natural log on the right side. We're doing that because now this E goes away. On the left-hand side, you have negative 0.044 T. And on the right-hand side, you have natural log of 400 over 500. And then your very last step is going to be divide. So we divide by the rate of negative 0.244. So this guy is what I'm going to plug into Desmos. And I'm going to plug it in exactly like that. So when I go to Desmos, I'm going to hit the fraction button first. So backspace. What was that all about? Backslash. Natural log, do a parenthesis, and hit your backslash again. 400 over 500, arrow down, negative 0.0244, and I'm getting 9.1. Raul, is that what you got? So when will there be 400 grams left? In 9.1 years. Every equation that you solve today will look like this. The natural log of some fraction divided by your rate. Okay, the next thing is a lot of your natural growth and decay, well, decay specifically, has this thing called half-life. And it's explaining that to you here. So half-life just means how long does it take for your starting amount to be cut in half. So we're going to do the question that says calculate the half-life of strontium. We're going to do the one that says calculate the half-life. So we're doing this one. Okay, well, let's make sure that we know all the pieces that we have. Our start was 500. We want to know when this will be cut in half. So what is half of 500? Divide it by 2 or multiply it by 0.5. 250. So you have to know that if it says find the half-life, you need to cut your starting amount in half. And now it's the same as it was before, except for we have 250 equals not E, 500e to the negative 0.0244t. Okay, step number 1 is we divide by 500. That's going to give you E equals 250 over 500. Then you take the natural log of both sides. These go away. So what you would be left over with is the rate equals the natural log. And then your last step is to divide by the rate. So what you plug in to Desmos is this. So if you plugged in the last one, all you have to do is change this top number to 250 instead of 400. So 28 years. 28.4. So the half-life of strontium-90 is 28 years. It'll take 28 years for your starting amount to cut itself in half. By the time we do the next one, I'm sure that most of you guys will see a pattern with this last thing that you plug in. So I'm not expecting you to show all of this work. I'm showing all of it so that you know exactly what I'm doing. You're welcome to do shortcuts if you have some. Okay, number 2. Instead of having an element like strontium, we have a population. So the 2000 population of Las Vegas was 478,000 people, and it is increasing at a rate of 6.28%. When did the population reach 1 million? Okay, well, 478,000 is our start amount. 1 million is our ending amount. 6.28 is our rate, but we have to turn it into a decimal. So we need to divide 6.28 by 100. So 6.28 divided by 100 is 0.0628. So now we set up the equation to match this formula. So your ending amount, 1 million, write it out the long way, equals, okay, I don't know where my recorder stopped, but you're trying to figure out what goes in these blanks to solve for t. In about 20 seconds, we'll check in. Ten. About 5. Okay, in the top goes 1 million. In the bottom, 478,000. So what do you get if you plug that into decimals? Do you need me to check it? Sure. I got 11.8. Anybody else? 1, 2, 3, 4, 5, 6. So go to decimals. Yes, sure. Hit your backspace first. Type in ln, parenthesis, hit your backspace again. 1 million over 478, arrow down, 0.0628. So 11.8 11.8 years. So it reached 1 million residents in 2011 because it started in 2000. Okay, next one is another population one. A population of a town decreases by 14.25% each year. So that's your rate. The town has 860 residents now. That's your start amount. In how many years will it be 300 residents? So you follow the equation. The end equals the start times e to the RT. And to find t, you will have some big fraction that you plug into Desmos. Let's go about 30 more seconds. $20. About 5. I got 7.39 years. In your quiz, it tells you exactly what to round to. So if this would have said the nearest whole, you would just say 7 years. Okay, before we do this money one, I want you to come down to the bottom and split this section in half. And I want to try one where it asks you to find the rate instead of the instead of the time. So instead of them asking you to find the rate, they're going to ask you to find, instead of asking you to find the time, they're going to ask you to find the rate. I need to find my paper really quick, so sorry about that. You can try the money one while I'm looking for this, but we'll come back to it in just a second. Okay, did you try the money one? Okay. So, money one. So, start is 1092. End is 3625.57. And rate is 0.06. If you plug all of that in correctly, your time is 20. Jeez Louise. 20 years, is that what you guys got? So I got 20.0000. Okay, let's look at the one that I thought that I had. So, there is a bacteria that is growing, and its start amount is 100. Its end amount is 9790, and T is 7 minutes. So what they're saying is it took 7 minutes for this bacteria to go from 100 to 9,790. They want you to find the rate. So at what percentage rate did this grow? So you're still doing this formula. But your exponent looks like 7r, 7 times r. So then r equals, it's going to look exactly like it has been on our other problems. I just want you to see what one looks like when they're asking you for the rate instead of the time. So you guys figure out what goes in those, and then we'll check your answer. Roughly 15. Okay, so if you did it correctly, one of these options should match what you got. So if you place the numbers correctly, Your answer should match one of these. What letter is it? C as in cat. Okay, one last kind, and it's double time. So here we did half-life. Here it asks you how long does it take for you to cut your population in half or your money in half. On this one, it's going to ask us to double. So it says a colony of bacteria that grows according to the law of uninhibited growth is modeled by this function. So that means that your starting amount is 100. And your rate is 4.5%. They want to know how long will it take for your population to double, which just means you need to identify the ending amount. So if we start with 100, what will it go to if we double? You're doubling 100. 200. Thank you, Hugo. So they're asking you how long will it take for this colony to double in size. So if your starting amount is 100, doubling that would be 200. So then you set up your equation. And let's round to the nearest whole this time. Let's round this one to the nearest whole. So like 20. $10. About 3. 2. Okay, I got 15. How about you guys? So this would have been 200 over 100 all over 0.45. Okay, give your quiz a try. They're all like